Welcome back. So in the last class we have discussed about our wireless charging and its methods and the different types of chargers and their constructions in the wireless. So what was the main advantage of our wireless charging? It was having no physical connection between the electric vehicle and the charger while it was charging. Limitation wise, when we go for dynamic charging, the initial investment is very high. So wireless charging will be requiring a huge amount of capital cost when we are going to dynamic charging. But the advantage of our dynamic charging was it was having minimum downtime of the vehicle, that is it is charging while the vehicle is still in the motion. So the downtime requirement was less. And after that we have started our discussion on battery management systems, that is our BMS. So this BMS, we have seen what will be the activities or the task which has to be done by the BMS whenever a charger is connected to the electric vehicle, we charge conductive charging or wireless charging. Always the BMS will be the one which will be the master. It will decide what will be the charging rate, what will be the mode of charging, and how much current it can handle, because the same charger can be used for different type of electric vehicles with different ratings. So BMS is the one which will be the master controller, and the charger will be the one which will be following the commands received from the BMS. So the safety, measurement, sensing, those things all will be associated with our BMS system. Then we have understood this, what is the meaning of depth of discharge and state of charge. Depth of discharge is the one which is telling us how much capacity has been used from the battery, whereas state of charge tells us how much capacity is still left or how much range we can obtain still with the battery, and we will be moving to a particular distance. So this will be mostly displayed on the dashboard of the electric vehicle, where we will be seeing the range left with us before it has to be recharged. So the depth of discharge is given by the current drawn into the time by the capacity of the battery, whereas the complementary, that is capacity minus of your current integrated over time by capacity, will be giving us the state of charge or the energy left inside the battery. Then we have understood what is the difference between the primary and secondary batteries. Primary batteries are mainly non-rechargeable batteries, so they will be used for the applications where single use is required and they will not be going for recharging it. So obviously these primary batteries are not suitable for our electric vehicles. Then the secondary batteries are the ones which will be having the recharge option, that is after the battery has been discharged we can connect the charger to recharge it. So obviously for our electric vehicle applications we will be going for secondary batteries, where we will be multiple times charging and discharging after using the vehicle. So now we have also seen the different types of battery chemistries and their advantages. More will be the specific energy, the less will be the size of our battery bank, and every other parameters also we have discussed. So what will be the implication of our charging and discharging cycle? The more is the charging and discharging cycle, more lifetime will be there with the battery bank, or it will be covering a greater number of years of usage compared to the one which is having less charging cycle. Then the nominal voltages of the battery single cell. Okay, so this cell will be used to construct the battery bank. So based on the voltage and power rating, it will be designed. So how the battery bank will be formed, we will see that in the next slide. The peak current capacity. So how this current capacity is important for us, we will also understand today. That the temperature range. So why this is important for us? When we are going for charging, when we go into the charging and discharging rates, we will discuss this thing in more details. So the temperature change should be such that it should be regulated within the given range. Suppose for example we are going for these technologies where the temperature has to be limited between 0 to 45 degrees. So our cooling arrangement should make sure that during using of our electric vehicle the temperature should never go beyond 45 degrees and below 0 degrees, in this case if you are going for this type of technology to develop our battery bank. So where it can go below 0 degrees in our hilly stations where the temperature will be in the minus, so there also we will be requiring some type of heating, internal heating arrangement to maintain the temperature between 0 to 45 degrees, whereas in most of the parts of our Indian continent we will be having this higher temperature. So we have to cool the system so that our temperature does not exceed 45 degrees, because whenever it is going to charging and discharging it will draw some current, and because of the resistances present in the path your heat will be generated. So we should always ensure that the temperature is between the specified limit of the technology used to construct the battery. Then let us understand the concept, that is C rate. So, the rate at which the battery is charged or discharged relative to its capacity, that is what is called as your C rate. For example, let us consider a battery to have 100 ampere hours. Okay, so this is the unit which is used to tell the battery capacity, that will be in the ampere hours. So, suppose 100 ampere hour battery is available with us. So, I target to draw an current of 50 amperes, then my battery will be having a C rate of 0.5 C. So, what is the meaning of that? So, I had a capacity of 100 ampere hours. Now, I am drawing only 50 amperes. So, it will be going for 2 hours for charging or discharging. If I am drawing the current to charge the battery, then it will be charging in 2 hours. If I am drawing to discharge it, so it will run for 2 hours. So, that is what is the meaning of C rate. Now, let us see, C rate is the parameter which will be telling us how much time it will be required to charge and discharge the battery. So, we have discussed about normal charging, our fast chargers. So, that is what is the parameter being changed, that we will be changing the C rate so that our charging can be done at a faster rate. So, we will understand that by considering the example. So, C rate will take 1 hour to charge the full capacity. If I go for 1 C, that it will take 1 hour to charge the battery. So, during discussing our fast chargers, we have seen that some chargers were designed to charge the vehicle from 0 to 100% in 15 to 20 minutes. So, there we will be going above 1 C rate of charging, so that its charging time reduces. Different battery chemistry designs have different recommendations for your maximum C rate. Okay, so what is the meaning of maximum C rate? So, as during our previous discussion, we have seen the temperature range which will be specified by the manufacturer. Now, if I increase the C rate, what is happening? Now, I am handling more and more current. Suppose for the same battery bank, we are, let us see the example, then we will understand it more clearly. So, here in this example, if you see, we have started with C by 10, the same battery capacity we have considered, that is 100 Ah. So, here it will be drawing a current of 10 amperes. Okay. Then it will be taking 10 hours to charge and discharge if I am going for C by 10. Similarly, let us go to the maximum case, 10 C. So, if I am going for 10 C, so it will be drawing a current or dumping a current of 1000 amperes, it will be charging and discharging in just 6 minutes. Okay. So, what is the meaning of increasing the C rate? I am increasing the current being handled by the battery or the BMS system. So, here the charger rating will be increasing because it has to handle higher amount of current. Similarly, on the battery side, if you see, the loss will be increasing because the current is higher. If we have some resistance, the battery model will be having various types of series and parallel connections of your battery and capacitors, which we generally use to model our battery. So, in that case, if we consider that it is resistive, so if I increase the current, the temperature will also be increasing because the loss is increasing. So, the main bottleneck of the design will be maintaining the or respecting the temperature limits, or indirectly maintaining the maximum, limiting our maximum C rate so that the temperature is not exceeded. So, if I not able to maintain this limit, what will be happening? So, I will be having an reduction in the efficiency, capacity loss, that is the battery capacity will be reducing, and even safety risks. So, it can, if the temperature is exceeded, it can be leading to fire accidents. So, if efficiency will be reducing because the losses are increasing. Capacity loss, it means and permanent damage to the battery capacity, and the last thing is the safety concern. So, obviously, when we are designing a charger, we should keep the BMS and the temperature management in their mind. That will be fixing our maximum C rate. From there, we can back calculate what will be the power rating of our charger and how much time it will be taking. Okay. So, the ones which we have discussed in our fast charger, it was taking 25 to 30 minutes. So, what is the meaning of that? They will be going for 2 to 3 C rate if you consider a 100 Ah battery. Okay. So, now from this discussion, what is clear with us? We have the information about the battery capacity and the C rate. We can calculate the charging and discharging time. Based on the charging and discharging time, one can also see what can be the current which will be handled by the system. Based on that, we can design the charger and the cooling systems, and our BMS can be designed. So now let us see from the cell. We have seen the cell battery voltages, it was very low as below the 5 volts. So how we design the battery pack? So first thing will be our battery voltage. Okay. So the motor ratings, so which we will be seeing in our next lectures, there we will see that motors will be rated to 48 volts or more than that, 48, 72, based on the power rating of the vehicle in which we are using the motor or the torque requirement. Our battery voltage capacity will also be increasing, its voltage rating will also be increasing based on where we are using, because the battery bank or the motor which will be used in an electric bike will be much smaller compared to the battery bank and the motor which will be used in a four-wheeler or an heavy electric vehicle. Okay. So here required voltage, suppose I have an 400 volt battery bank system and my each cell is generating suppose 4 volts. So I have to connect 100 of them because I want 400 volts. Ideally I have to connect 100 of them in series so that the voltage, required voltage is achieved. Now parallel connections. So how the parallel connections will be decided? Based on the capacity. Okay. How much capacity? In the last slide we have discussed about 100 Ah. Based on that capacity I can calculate, I have 100 cells in the series. Now based on the capacity requirement I can connect them in parallel so that the required capacity of the battery bank is achieved. Issues why should be kept in mind while designing the battery pack is cell balancing. Now I have hundreds of cells connected in series and parallel. Now I have to balance them. Okay, so what will be the issue if I am not having the balancing algorithm? That we will be seeing in the next slide. Safety issues. We have already discussed the temperature limit has to be maintained while charging and discharging. So we should keep this temperature limit and other safety except which we have discussed in the last lecture. So all those safety concerns has to be addressed or kept in mind while designing the battery pack. Carefully electrical design so that every cell gets equally charged at discharge. Okay, so while keeping the battery pack, designing the battery pack, we should keep in mind that every cell should be equally charged or discharged, or else what will happen, the cell which is subjected to more rate of charging and discharging may damage first compared to the other cells in the battery pack. Materials. So in that while designing our battery pack, material will also play a major role. Why? We have seen that different technology has different types of wattage for kg, or the energy density was different for different technology. So the material used will also play an key factor while designing or determining the size of our battery pack. Cost of the material and availability. So even if some technology suppose has a very high energy density, but if it is not available for the manufacturing purpose, so it should not be used. And the cost of material should not be very high, so that it will not be attracted by the customers. So we should keep these two factors in the mind, that the cost as well as availability should be there so that the electric vehicle battery pack can be manufactured. Then in this cell configuration, what are the things which we should keep in the battery pack designing? That is, first is series parallel connection. We have discussed, based on the voltage rating we will be going for series connection, based on the capacity we will be going for parallel connections. Then the structure of the battery pack. So case, cover and end plates. So when we see the structure, these things has to be kept in mind, that is casing, cover, end plates, tie rods, cell holders and base plate. These are the mechanical size. If you see, these are the mechanical components which are classified into the structure component. Then brushes, wiring, harness, fuse and plugs. These are the electrical components which will be falling on the structure part of the battery pack. Cooling jacket, safety valves and thermistors. These are the thermal management experts of our structural battery pack development. Then the safety concerns which should be kept while developing the battery pack. First is vibration, shock and abuse and crashes which can occur during the use of the vehicle. So this will be classified under the mechanical challenges of the safety. That short circuit, overcharging and over discharging, these are the safety concerns on the electrical side. Thermal runaway and thermal management, this should be the concerns which should be classified under the thermal of the safety limits. Okay, so if we are not considering these things or keeping in mind while developing the battery pack, we can have serious issues with the electric vehicle usage. So, we should keep these parameters under control or under observation, and the BMS should have the functions of maintaining these things: control, vibration and control, and hardware robustness. This should be on the mechanical side, and cell monitoring and BMS it should be on the electrical side. So, the control and everything will be done by the BMS. So, while developing the battery pack, we should keep all these parameters in mind while designing it, so that mechanical, electrical and thermal issues are addressed, and as well as the required capacity and required voltage is obtained from the battery pack. Now, let us understand what is the importance of cell balancing. Okay. So, from the previous discussion, it is quite clear that every battery pack will have hundreds of cells connected in series and parallel. Cell balancing is equalizing the SOC of different cells, so that the performance of the battery system is maintained. Okay. So, here if you see equally distributed levels of charging. So, here if you see the SOC is balance, whereas in this case if we are not having the cell balancing, what will happen? Suppose this cell is subjected to higher rate of discharging. So, if you see that it has been discharged the maximum compared to the other cell. So, what will happen? So, the aging effect and this cell will be putting a limit on the operation of the other cells in the battery pack. So, we should always ensure that they are equally charged and discharged, so that optimally or the best performance from the battery pack can be achieved. So, now how we balance the cell? So, that we will be seeing different methods of cell balancing shortly. So, SOC, self discharging rate, capacity, impedance and the temperature characteristics are different from one another in the battery pack. So, we will have various cells, and each cell will be having a different parameter, because none of the two cells will be perfectly identical. It is impossible to make identical cells, even though the technology or the material used for the cell manufacturing is the same. Every cell will have slightly variation in the these parameters which are listed over here. Then cell are balanced based on the measured VOC or the open circuit voltage. So, here we will be having a requirement of information of the instantaneous battery voltage. Okay. So, most commonly we use this information to balance out our cell SOCs. Then different types of cell balancing. Now, inside a battery pack we have hundreds of cells. Now, we want to equally charge or discharge them, so that the aging or the lifetime of the battery pack is uniform and optimal use is obtained from the battery pack. So, this is classified into two different categories. First is your passive cell balancing, active cell balancing. When we discuss about the practical usage, passive cell balancing is more popular compared to the active cell balancing. So, we will see why it is so after discussing each one of them. Passive cell balancing, in this passive cell balancing, it is the simplest method. So, we will be using passive components such as your resistors and capacitors to balance out your cell voltages. It is used in places where the cost and sizes are major constraint. Okay, so, it will be the simplest or the cost effective solution. It has two categories. First is charge shunting and switch shunt resistor. Okay. So, we will see each one of them. The fixed shunting resistor. So, in this charge shunting or fixed resistor based method, here every cell, if you see, it is connected across an resistance. Okay. So, in this method, a dummy load is like a resistance is used to discharge the excessive voltage and equalize the cell voltages. Suppose some cell is having excessive charge, it will be discharged through the resistor. The fixed resistor circuit uses n number of resistors connected in each cell to prevent it from being overcharged. Okay. So, during charging and discharging, this resistance will be helping us in maintaining the cell balancing. Fixed shunt resistor method is used mainly in the lead acid and nickel battery pack applications. Okay. So, wherever we are going for this lead acid or nickel batteries, there we go for fixed shunting resistor method. Fixed shunt resistor circuit requires low cost because it is very simple for construction. We are just using the resistances which are very cost effective. Then switch shunt resistor. In this case, if you see what is the change, here we have an switch. which is used, and we have an control signal which will be turning on and off the switch as per the requirement. This a switch sending resistor uses n number of switches for with n number of resistances. So, for each cell we will have one switch and one resistance. So, we will be using n of them for the battery pack. The most common method in cell equalizing system. So, this method is divided into two different modes, continuous mode and sensing mode. As the name suggests, in the continuous mode all the switches are controlled to be turned on and off at the same time. In continuous mode they will be turning on and off simultaneously, whereas in the sensing mode this method requires real time voltage sensing, and based on the sensed voltage we will decide which switch has to be turned on or turned off. So, the cost effectiveness wise, so this will be a bit costlier because we will be requiring sensors, whereas the cost of continuous method will be slightly less because here we are not sensing, but we are turning it on and off at the same time simultaneously. This cell balancing circuit is suitable for batteries which requires low current when it is charging or discharging. This method is suitable when we have lower C rate, that is lower charging and discharging rate. Then the next method is active cell balancing. As the name suggests, active cell balancing. During this time the cell will be continuously equalizing their energies while they are in the charging or discharging mode. This method is classified based on what component is being used, whether capacitor is being used or inductor or power converter is used to balance out the energy. We classify it based on this. So, in this capacitor method, this method will be equalizing the energy both during the charging and discharging. It is highly effective, energy efficient, and quick balancing is achieved in this case. Every merit comes with some limitation compared to the previous passive energy balancing techniques. This method will be costlier. The circuit is complex and cost is high. Active cell balancing types: capacitor based active balancing method, then active cell balancing circuit based on inductor and transformer. Okay. So, these are the types. So, here first type is capacitor based, second type is our inductor or transformer based, third type will be our power electronic interface based, where we will be having a converter which will be balancing out our energy. So, let us see each one of them. The capacitor balanced active type of balancing. In this active balancing method we will be using capacitor. Okay. So, here in this method also we have different types based on the number of capacitors which are used. So, suppose when a specific cell voltage is lower than the capacitor voltage, this cell is charged by the capacitor. So, what will be the working principle of this one? We have an capacitor which is an temporary storage of our energy. Whenever we detect that the cell voltage is less than the capacitor voltage, obviously the capacitor will be charging the cell. When a certain cell voltage is higher than the capacitor voltage, the cell will be discharged to the capacitor. So, what is the meaning of that? The energy, excess energy, because it is having an higher voltage, the excess energy will be removed from the cell and it will be stored inside the capacitor. Energy is transferred from the cell by the capacitor. Thermal losses of the cell balancing circuit are usually lower than that of our passive method. So, why the efficiency will be higher? Because the thermal losses in the circuit is less compared to the previous one. So, in this capacitor balancing method we have two different types, single capacitor and multi capacitor. Okay. So, based on the cost available with us and the user requirement, we can go for any one of this method. Compared to the active cell balancing and the passive cell balancing method, active cell balancing method is a better effective way of managing the cell balancing, whereas it comes with a higher cost. Then active cell balancing circuit with power electronic interface. So, that will be the most complicated one or the most costly one. So, we will see each one of them. Active cell balancing using a single capacitor, where we will be having n number of cells and n plus 2 number of switches and one capacitor. Okay. So, if you see this arrangement, it seems to be quite complex. So, based on the cell which is having over voltage or under voltage, we will be selectively connecting these capacitors. We have understood when the capacitor will be charging or discharging. Whenever a cell voltage is higher than the other cell voltages, we will be using the capacitor to remove the excess charge. When the vice versa condition is true, that is some cell is having a lower voltage, we will be connecting this capacitor across that cell so that it will be charged and the voltage will be equalized. The capacitor is charged and discharged in the string to equalize the voltage. Based on that, we will be providing the control signal so that the capacitor gets connected across that particular cell which has to be charged or discharged. It is simple balancing circuit which uses single capacitor regardless of the cells, number of cells, 100, 200, irrespective of the number of cells, we will be using a single capacitor. So, the number of capacitors will be less in this case compared to the other solutions. It uses large number of switch and intelligent control of switching circuit. So, if you see, the switching arrangement is quite complex because the single capacitor has to be connected across hundreds of cells as per the requirement. So, we will be requiring large number of switches so that the same capacitor can be connected across any cell as per the requirement, and the control should also be efficient so that it will be connecting the capacitor to the required cell. Then multiple capacitor method. So, here if you see, we will be using multiple capacitors to charge or to transfer the unequal energy that is present with the capacitors. So, here we will be using multiple capacitors. So, the cell balancing is composed of n number of cells, switches will be your n minus 1 capacitors will be there and switch will be equal to the number of cells. So, in this cell balancing technique, if you see, so in between our battery 1 and battery 2 we have an capacitor. So, that is why for n number of cells we have n minus 1 number of capacitors, and we will have switches based on the cell which is charged or discharged, we will be connecting and disconnecting it. The advantages of this cell method is that it is not required to sense the capacitor voltages and closed loop control. So, as we are using multiple capacitors, we will no longer required to sense the voltage or go for closed loop control. So, it will be bit simpler compared to the previous case where we were sensing and connecting the particular capacitor across the particular cell. The stress of the switch is lower in this case, however, its balancing speed is not satisfactory. So, what is the meaning of that? It will take a larger time compared to the previous method to balance out the cell which is having unequal energy. Then the next method is using inductor and transformers. Okay. So, in this case, if you see the simplest one, here two battery banks are connected, we have two switches and an inductor in between. This method uses magnetic components such as our inductor or transformer to equalize the cell voltages. The cell balancing results in each cell to be equalized by transferring unequal energy from the higher cell to a lower cell in the battery pack through the inductor or transformer. So, what is the meaning of this one? Whichever will be having higher energy, it will be transferring the energy into the inductor. Whichever is having lower energy will be absorbing the energy from the inductor, and inductor will be used as a buffer storing element. Okay. That the cell equalizing circuit has higher production cost, and magnetic transformer loss should be considered during the designing phase of this cell balancing circuit. So, what are the limitations of this method? So, its production cost will be higher because you will be using inductors and transformers which are costly compared to the previous solutions. Then we have magnetizing inductor and transformer in the circuit. So, the losses will also be increasing in this case. Then the most sophisticated case where we will be having an power transient converter to balance out our cell energy. So, here if you see a simple flyback converter which we have discussed during our charger discussion stage. So, flyback converter, it was the simplest isolated DC-DC converter we will be using a transformer. So, here if you see a multi output flyback converter is used, that also we have discussed during our charger study. So, flyback converter, here it is used. So, it will be an flyback or forward as per the application requirement. Flyback will be the cheapest one because it has minimum number of components. While discussing our flyback and forward converters, we have seen these things. Cell balancing with flyback capacitor, it uses n number of cells, then we will have n number of diodes in the circuit, and transformer with n number of output terminals and n single MOSFET. Okay. So, it will be used to use like similar to an flyback converter. Whenever the switch will be on, the transformer will be storing the energy. Whenever it is off, it will be transferring the energy, so that the cell balancing is done. The energy of the voltage is stored in the transformer. Whichever will be having an higher cell voltage, it will be transferring the energy into the transformer whenever the switch is on. When the secondary switch is turned on, the energy transferred to the lower voltage cell through the diodes. Okay, so when we are turning on the switch, so it will be transferring the energy to the cell which will be having lower voltage by using the diode. Okay. The cell balancing method can be usually implemented in large number of cells, because we have to just repeat the secondary side of the circuit. The primary side is constant, that is one switch, and the primary side of the transformer coil is used. So, it is most commonly used in our electric vehicles out of the all active balancing methods. So, we will be continuing from this slide in the next class. In our lecture today, what we have discussed, we have seen the different types of charging rates, C rates, and we have seen the number of challenges which will be kept in mind while designing the battery pack. We have seen how to achieve the cell balancing and importance of cell balancing and the types of cell balancing in this lecture. We will continue from this point in the next class. Thank you.